Thank you to TotalBoat for supporting this project. This is a pecan slab I got from a friend of mine, Ted Alexander, in Oklahoma in 2017. And in this video, I'm going to show you how I turned it into a beautiful table with a somewhat hidden drawer. The first step was to examine the slab and determine a game plan. And apart from the obvious voids and cracks that you can easily see, it was full, absolutely full of small cracks and bug holes here and there. House wrap is commonly used in epoxy projects, but I went with regular clear packing tape instead. It's just much cheaper, actually a lot cheaper, and I already had a lot of it on hand. I put a layer of tape over the major areas first, and then a layer of tape over the entire top side. I figured it would be easier to pour from the bottom side first, as the larger bark inclusion in the center would be easier to fill that way. I'm only using the epoxy to fill in the bark inclusion and the cracks, and I won't be, I guess, suspending the table in epoxy around the perimeter, kind of like a river table. So rather than a melamine form, I decided to use some wax paper to kind of gift wrap the entire slab. This will allow me to flood the slab with epoxy and hopefully stop any extra from spilling out. The epoxy I'm using is TotalBoat High Performance with medium hardener, and I'm also tinting it black with some epoxy dye that a friend of mine left in the shop a couple of years ago. The bottles of High Performance say that you need to mix it for at least 2 minutes, so I recommend picking up a cheap kitchen timer to dedicate to this task. We all use our smartphones for everything, and I really don't like the idea of getting sticky epoxy fingers touching my cell phone. Here's a mistake. I started the first pour without using caulking as an epoxy dam to focus the location of the pour. That was an instant "you're a dummy" moment as I started to pour. Luckily, it's the first pour, which means all of the voids can accept the most amount of epoxy at this time. After letting the first pour set up for a while, I added the caulking to create a dam around all of the major flood areas. And here's a quick tip for you. Store a few large wire nuts near your caulking tubes and use them as caps to prevent the opened tube from drying out. Alright, mix number 2. Now, I'm not a big volume epoxy user. I mainly just use it as adhesive for joinery. So I had no idea how much I was going to need or how much I should have mixed with each batch. Mixing smaller batches like this also guarantees that I'm not going to pour much thicker than the recommended layer height for this product. Here's another mistake. The caulking dam keeps the epoxy concentrated unless you're a dummy like me and just pour way too much at a time. So at this point, I had not only a dam, but also a spillway. More of the same, just flood the defects. Now this second pour was better in that I didn't have to babysit certain areas, just fill the epoxy and watch the bubbles come up as the epoxy flows into the cracks. This area had so many small cracks, so I just figured flooding the entire area was a good option. Here's another pour on, I think, another day. I was working on this right before Christmas, so mixing and pouring a little bit while I walked away and did something else was actually pretty convenient for my holiday schedule. After a few more days, I flipped the table over to pour from the other side. Now I could remove all the packing tape I had on the bottom, and it actually worked much better than I had anticipated. At this point, the bottom side should be pretty sealed, so I didn't add any tape or wrap it for the remainder of the pours. I did add some more caulking to the top and a few areas on the end grain. I had some pretty old slow hardener that I needed to use up, so that's why this batch kind of starts out yellow. The age kind of made it yellow, and I'm not sure how much of the age affected the chemical composition of the epoxy, but I rolled with it. Once again, here's some more pouring of the epoxy. I think this was day 375,000 of this project. I'm not exactly sure, I lost count. With the epoxy work hopefully done, I finalized the base design and picked out a single ash board for all of the pieces. Step 1 on the base material is to mill the lumber starting at the miter saw station, and after all of the cross cutting on this board, I noticed some internal checking. It was kind of minor, but I really didn't like it. Every bit of this board went right into the scrap bin. So that was kind of a bummer, but onward. On take 2, I picked out 2 smaller boards that looked pretty clear of defects. I cross-cut them to rough length at the miter saw, jointed one wide face at the jointer, planed the opposite wide face at the planer, then back to the jointer to joint one narrow face, making sure to go in the downhill direction, and then completely stopped the milling process. This was the morning of Christmas Eve, and my main goal was to get the milling process started so that they could rest over the next few days while I was out of the shop and focused on family time. A few days later, and a few pounds heavier from the holiday food bombardment, I started the flattening process. Now, some people have asked in previous videos how I hold down the slabs when flattening on the CNC, and my answer is that I don't. These slabs are too heavy to lift up on their own, so the only concern is to just prevent lateral movement. I always start, if possible, by pulling the slab against a few bench dogs and then using my wide stop blocks on the other side. If the slab has any cup or twist to it, I'll divide the high areas by using wedges along the high diagonal. This one laid pretty flat, so no wedges were necessary. The bit I'm using is a Bits & Bits SB25-2. It is a 2.5 inch diameter surfacing bit with 2 replaceable Astra-coated carbide inserts, which I'll get to in just a second. I'll leave a link in the description down below for a video on my second channel where I tested this bit out to determine the proper feeds and speeds. I normally use the manual jog feature to shave off the high spots before I run an actual program, and in this case, I got a little carried away and I got nearly the entire slab surfaced manually. Unfortunately, the cut quality was not good at all. I had a lot of burning areas, which means either the bit is traveling too slow and rubbing, building up heat, instead of cutting, or the cutting edge is dull. Now, I had the machine jog settings set to the appropriate feeds and speeds of the bit, so it wasn't that. The problem was the carbide inserts were pretty dull. As I rotate the inserts, here is a cost breakdown of using this bit. The initial cost of this bit is, wait for it, $399. And that comes with 10 extra inserts. That sounds crazy, but it's actually not. That's 12 inserts with 4 cutting edges per insert for a total of 48 fresh cutting edges. 2 inserts are needed at a time, so divide the 48 cutting edges by 2, and this one bit purchase is basically the equivalent of 24 new flattening bits. So $399 divided by 24 equals $16.63. So if you're using this over and over again, you can see how the replaceable carbide inserts are actually a big long-term cost savings. After you go through the included batch of inserts, you can get another 10 pack of replacement inserts for $82.50. Do the same math. 10 inserts times 4 cutting edges divided by 2 per setup equals 20 setups. That means each fresh setup costs a mere $4.13. That is a huge cost savings versus buying traditional carbide tipped bits. One more pass with a 0.125 inch depth of cut and a 1.65 inch step over, and you can see a much better result. Regarding how long the inserts last, I used the previous cutting edges for a couple passes on each side of this Osage orange slab, and I was also doing some feeds and speeds testing, so I was cutting way too aggressively, a lot of that. And a couple passes on each side of this cherry and epoxy river table that a friend of mine brought over to flatten. I also used it to flatten the entire CNC spoil board once, so everything that I just mentioned, plus one roughing pass on this pecan slab, had a router bit consumable cost of $16.63. I'm not sure how entirely necessary it is, but I decided to flip back and forth to remove a little bit from the either side to work my way down to the final thickness, similar to a typical milling process. You want to take a little bit from either side. The goal here was to release the stress in the wood little by little and prevent any warping that may occur. This slab remained perfectly flat through the rest of the build. At this point, both the top and bottom have been surfaced and some new defects are starting to show up. Some areas where the epoxy didn't flow into, and a few large worm or bug holes packed with dust, both of which I cleaned out the best I could with some compressed air and an awl. You guessed it, more epoxy. I really didn't want to make a mess this time, so I used a paper funnel to pour it into a Harbor Freight storage bottle. These little bottles hold 8 ounces of liquid, and they have a pretty small hole in the nozzle, which is great. They come in a 3-pack for like $3.27, so relatively inexpensive. They're also super handy for stuff like mineral spirits, denatured alcohol, and lacquer thinner, which I keep in my finishing cabinet. As it turns out, these are super handy for epoxy as well. This is great for forcing the epoxy in one end of the defect and watching it fill from the bottom up. That visually ensures that there's no trapped air. Much better than just flooding it from above. I let that dry overnight, And on day, I don't know, 482,000, I cleaned up the top surface once more with a small 0.05 inch depth pass with a 0.5 inch step over. I wanted to be as conservative as possible cleaning this up. At this point, all of the major voids were filled with epoxy, or so I thought, so I switched over to medium CA glue to fill the super tiny areas. Using a light raking across the surface is great for highlighting all of the tiny stuff that blends in, is just so hard to see. Finally, I determined all of the CNC work on the top surface was done, so it's back to the bottom side. My original plan for the legs was to use through mortise and tenons in the shape of a dog bone, like I did on a recent bench, but at this time, I decided against that. The top already had so much going on visually, so I thought adding a dog bone would kind of take away from the natural beauty of the wood. I laid out the location of the 4 legs and the 2 sliding dovetails, and you'll see a lot of these slab tables with inlaid C-channel on the bottom to prevent warping of the slab. Instead of C-channel, I decided to make sliding dovetail rails so I could add a low-profile drawer. Once I had everything drawn onto the slab, I used a center point pin in the spindle, just hand tightened, to locate all of the necessary joinery and then transfer those coordinates from Mach 4 to VCarve Pro. From there, I could create all of the cuts. Instead of dog bone tenons, like I said, I went with a triple mortise and tenon joint. This provides a ton of glue surface area to create a strong joint. The mortises are just 3 slots with a 0.5 inch spiral upcut bit. For the tenons, the vertical table is used. First, a shoulder is established, and then a spiral profile cut is made for each of the 3 tenons. Rinse and repeat for all 4 legs. A test fit confirms the fit, and you can see the mortises are a little longer than the tenons are wide. Now I did this just because it's easier to do, and it also allows a little bit of room for the epoxy to squeeze out. Next up is the sliding dovetail work, starting with the bulk removal of the material with a 0.5 inch spiral bit. You can see that they won't be the same length. My concern here is that they are both the same distance away from the opposite edge of the table. I don't care how long they are, they just need to be the same amount inset from the ends. For the dovetail shape, the spiral bit is replaced with an 8-degree dovetail bit. I haven't pushed this dovetail bit before, so I don't know how much waste removal it can actually handle. So I got the final shaping of the dovetail slots by a series of full depth profile cuts to sneak up onto the final width. I also was able to control the start and stop location of the cut this way. A profile path is better in this case because it can force the start and stop location to be outside of the material. That way you don't raise up and break out the side of the dovetail. To make the male side of the joint, I put the same bit into the router table and made a test cut on scrap stock. The first test let me know that the bit was just a touch too low on the router table, so a slight adjustment and the test pit matches the female side of the dovetail perfectly. With the proper height established, the actual material can be cut with the fence set so that the resulting piece is too wide. The plan is to make successive passes while moving the fence back a tiny amount until the perfect fit is achieved. Everything was going according to plan until the fence position slipped without me catching it. The resulting fit was too loose. Bummer. Luckily, the pieces were still oversized in the height direction. The height was also the only dimension that wasn't covered in the rough milling process, so one rip at the table saw to square up the final face, and another rip cut with the new face against the saw fence to remove the dovetail completely and establish the final height of the rail. Alright, take 2 at the router table to get the appropriate fit, and luckily this time I got it. The end of the dovetail slots have an interior radius and not a sharp corner, so I had to remove some material so the corners would fit. No need to be exact with it, as it will never be seen, so I just made a simple plunge cut into the fence opening at the router table to kind of clip those interior corners. Now the length of these rails needs to be established, and the joint was pretty darn tight, so I didn't want to seat these all the way in. So with them resting in the slots kind of on a diagonal, and pushed all the way forward, they will both be the same distance from the opposite edge. I used a square pushed in the same distance from the front edge to mark the length of both rails, and they can be cut to their final length at the miter saw. I decided that the easiest way to make a drawer runner was to add a strip of wood to the bottom of the rails that the drawer could slide on top of. Now, I already had some surfaced walnut scrap on hand, so I used that and glued it right to the rails with the plan of trimming it to size later. Switching back to the legs, I cut 2 tapers on the bandsaw to give the effect that the entire leg is angled in one direction. The legs will be installed so that the legs are splaying out slightly. The bandsaw and faces are cleaned up pretty easily with a hand plane. And then all of the leg edges get a generous 0.5 inch round over. It's important to chamfer or round over the bottom edges of table and chair legs. If you don't, the outside faces are much more likely to snag and splinter off if the piece is dragged across the floor. Back to the drawer runners, they are first cut to the final length at the miter saw, and then they're cut to the final width at the table saw. When gluing these pieces in place, I made sure to overhang the walnut only on one side. This way the ash is used as a reference face against the fence to cut and establish the final width. This new walnut face is now parallel to the ash, so it can be ran against the fence to establish a slight bevel on the outside face of the rail. I thought something was needed to minimize the blocky look of the rails, and this was basically the simplest solution. I also thought that the walnut looked a little too thick at this point, so I reduced its thickness before leaving the table saw. Here you can get an idea for how the drawer rails will work, and you can also see that the bevel cut does a lot to break up the shape and make it feel a little bit more like the rail belongs on the table. I'm using epoxy as an adhesive because the joints are tight and I don't want any PVA glue expanding the wood, making the joints frustratingly tight during assembly. Starting with the legs, a generous amount of epoxy is applied to the mortises and the legs are hammered home and then checked square before moving on to the next one. The primary reason for these rails is to keep the slab flat while still allowing for expansion and contraction. That means the entire rail should not be glued in place. I only added epoxy to the last couple inches of the slots, leaving the rest of the joint free to slide as needed. Because I wanted the rails to be inset the same distance on both ends, some of the dovetail slots were left exposed. I didn't want to leave it like this because of clothing potentially snagging on the corners, so I used some of the same ash as the rails to make basically dovetail plugs. These were left epoxied in place, leaving an inch or so gap between the plugs and the rails for expansion and contraction. The last bit of construction for this build is the drawer, and I milled some of the scrap ash from earlier in the build for the 4 sides, and every bit of it was a beautiful straight grain with a decent amount of curl to it. I went with box joints for the drawer joinery, and this was the first time that I tried making vertical table joint cuts without first running a shoulder scoring toolpath, and the results were great. A quick test fit of the joint confirms the fit, and the rest of the joints are knocked out. A couple stop blocks in the vertical table direction make batching out all of these cuts quick and easy. Now, I'm not sure how much of the clean cuts were due to not being aggressive with the cut versus the great cutting properties of ash. Ash is probably my favorite hardwood to use with a CNC machine because it just cuts so cleanly. For assembly of the drawer, I used hide glue. And hide glue is another great glue choice when you want a little extra open assembly time versus PVA glue. Hide glue also lubricates the joint, which is my favorite reason for using it, versus PVA glue, which swells the joint and makes it harder to assemble due to its water-based nature. I didn't use any clamps on the drawer as the joints were tight enough to not want to move once seated. I just made sure that the drawer was square and set it aside to dry. Because the drawer was already on the short side, I didn't want to waste any interior drawer height by putting the drawer bottom in a dado. Instead, I set up the router table with a rabbiting bit to cut a rabbet on the bottom side of the drawer. This will maximize the interior drawer depth. I made this entire rabbet cut in the climb direction. Making climb cuts with a router will guarantee no tear out, but it also makes the process a little bit more challenging. meaning that the direction of the bit was wanting to climb the material or pull the drawer away from me the entire time. The rabbiting router bit creates a radius for the inside corner, so either chisel the radius square or round the corner of the bottom panel, which is the route I took. The bottom panel is cut to length and width at the table saw, and then the radius on the corners is established with a belt sander. A small amount of fast setting glue is added to the interior corner of the rabbet, and the panel is set in place. Rather than clamps, I used some scrap wood and steel weights to add some downward pressure. While the glue sets on the drawer, I sanded the legs and broke all of the edges on the dovetail rails. I also sanded as much as I could on the bottom with an orbital sander. Once the drawer was dry, I cleaned all of the sides at the belt sander. I have a precision miter gauge for this machine, so once dialed in, it's pretty fast to sand objects square by rotating the freshly sanded face against the miter gauge fence over and over again. Here you can see how the drawer will work. The drawer can slide in and out from either end, and the square end will be facing the main seating area, while the angled end will be into the open area of the living room. I contemplated not adding a drawer pull at all because it will be pretty easy to pull the drawer forward by lifting up slightly on the bottom edge, but I ended up cutting a 0.75 inch hole in the front and back just in case. Now, after having the table complete for a few weeks, I can say that this step was kind of pointless. We always just pull the drawer up and forward from the bottom. With all of the building done, some final detail work can begin, and the first detail was to cut the 3 ends of the slab to their final length. On the very first cut, I revealed a few internal defects that didn't get filled with previous steps, so yay! More epoxy work. Luckily, the second and third cuts didn't reveal much. Time to pause once again and fill the exposed areas with more epoxy. After another night of letting the epoxy cure, I was able to start cleaning up the edges. I have a Rotex sander that can remove material so fast. Add the foam contour pad and it's a perfect tool for stripping the slab edges while still maintaining a natural edge look. Even the end grain dovetail plugs are no match for the sander. It's just such a time-saving tool. For the top, I switched out the contour foam pad and stock medium density pad for a hard density pad. The hard density pad does a better job of keeping the surface flat and preventing any minor dishing from softer areas being removed faster. Finally, a finish can be applied, and my go-to finish for the past year or so has been a basic oil wax finish. Nothing fancy, but it really does make a good job of highlighting the wood grain. It's not incredibly durable, but it is incredibly repairable for refinishing or touch-ups down the road. Also, I'm not sure how well it's showing up, but after applying the finish to the top, I noticed I didn't do a good enough job sanding, and I still had some of the milling marks from the CNC work. So it's not shown here, but I did have to sand off half of this finish on the top, get rid of the marks, and then reapply the finish. The drawer got the same treatment as well, and I like how simple the whole drawer system turned out. It's basically a tray. I can move this around as needed, although it's going to live its whole life underneath the table. Here's a few close-ups of the table while still in my shop, and the wood just speaks for itself. There's a lot going on. There's some spalting here and there. There's some curl and compression features in the crotch section. There's larger cracks that are stabilized and highlighted with the black epoxy, and the bar conclusion is filled with the epoxy as well. There's so much naturally going on with this slab, and now that I'm finished, I'm really glad I did not distract from that beauty by making the leg tenons through tenons. And here are a few final images of it in place in our living room. The non-symmetrical shape of the slab, it aligns perfectly with the non-symmetrical shape of our sectional. This is a great piece for this exact scenario. And the most important thing is that my wife loves it. So yay. That's it for this project. Thank you to TotalBoat for supporting this build. Be sure to go to jayscustomcreations.com/newsletter to sign up for my email newsletter so you don't miss anything that I publish. Give this video a thumbs up if you liked it. I would very much appreciate that. Subscribe if you haven't already done so, and I'll talk to you in the next video.